Okay, let's continue to next topic. Okay, after static analysis, of course, it should be dynamic analysis. Okay, there are several different techniques can be used by static dynamic analysis. So let's take a look at this slide, which is T11, right? So that is T11. Topic 11, dynamic analysis. Okay. Of course, we can collect a lot of malicious software and try to execute those malicious software in a sandbox, as I mentioned before. But it is quite complex to do such a kind of thing. So there are some research team, okay, including myself. We provide some service for all the other research team. Okay, you can upload your malicious software to our system, and our system will automatically deploy a brand new virtual machine. Okay, and we execute those malicious software in our virtual machine and wait for about 5 minutes. And in this 5 minutes, and we will monitor all the Windows function, Windows API call function executed by the malicious software. All the files accessed by the malicious software. All the network packet sent or received by the malicious software. All the registers touched by the malicious software. All the libraries loaded by the malicious, and so on and so forth. Okay, we can find a lot of those dynamic profiling service from the network. Okay, so here is an example, okay, which I would like to show you. This example is called DELF, DELF. Okay, DELF, and its MD5 is right here, 0C blah 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 blah. So basically, you can check it out by using VirusTotal. Okay, in VirusTotal, okay, in its front page, you can in the front page, okay, you can click search, this search button, and you can simply just input the MD5 value of this sample, or click the name if you know what name this is. What name? DELF 0C4. Okay, see if we can find. Okay, there are a lot of malicious software which has the same name. Okay, so maybe we can take some time to. Okay, there are too many of them. Okay, we can do it at home. Okay, so we can simply just check it out, check the information in the virusTotal.com. Okay, but in here we like to do dynamic analysis, right? So the very first thing I'd like to show you is I'd like to know what Windows API calls that the malicious software invoke when we monitor this malicious software. So here is, of course, we cannot provide you the profiler, okay, because it's a little bit complex for you to run those sandbox. So I provide the logs, log files. Okay, so here you can get this log file, which is called 0C4946 underscore 314.hook.log. Okay, you can simply download it. Okay, because I prepared it for you. So let's take a look at this log file. Okay, it contains, okay, the following lines. Of course, there are a lot of lines. That is the first, very first 21 lines. The first line is 3140. It is just an index. Okay, so it does not have any meanings. And then its name. Its name is malware.exe. It's meaningless. As mentioned before, the name of this malware is meaningless. Okay, so the most important part is right here. Okay, take a look at this one. There are several sections. Okay, divided by sharp. Okay, sharp 2235100. That means time, a timestamp. Okay, that means timestamp. At this timestamp 2235100, this malicious software invoke a specific Windows function. Okay, the name is load library. So basically, it is a function, load library. So that means the malware intend to dynamically load a library. So you want to use this library. And which library it is? There are two additional information. The first one is the library it invoked, which is INN32.dll, which is the name of this dynamic load library and linking library. Okay, and at the end, the return means says it is success, which means this library is successfully loaded by this malicious software. So that is the very first thing that this malicious software invoked. Of course, but there's a question that how many functions provided by Windows? There's a small set. It's around 3,000. Around 3,000 functions are provided by Windows. But there's another bigger set, which is almost 30,000 libraries, functions provided by Windows 32 API libraries， 就是有一个比较小的集啊，大概有3000多个 functions， 比较大的大概是3万多个，所以你可以在 Windows 里面就是 include 它就好了，或 import 它，然后你就可以呼叫那些 function。However, from analyzing perspective, it is not practical to analyze all those 3,000 or 30,000 functions. So basically, you can see that we can select some important Windows API functions, and we believe those functions are very critical from different aspects. 就是说，你叫我们去监控那3万多个 functions 有没有被呼叫到，或者那3000多人被呼叫，其实有点不切实际的啊，因为有些 function 其实很少被呼叫到，所以我们有时候做 dynamic analysis 的策略是，我们会 observe 我们认为有价值想要看的 functions， 那些 function 就不外乎是档案操作啊 ，register 的改变啊，有没有生出新的 process 啊？有没有去读取记忆体啊？有没有操作哪些档案啊？操作哪些Windows socket 啊？就是你会制定出一些你认为比较重要，能够形塑这个 process 这个 program 到底在做什么事情，然后你会只观测那一些function就好了，这会比较有效率一点。So that in practical we will not monitor all those 30,000 functions provided by Windows. Rather, we will select some important functions like file access, socket programming, like library invocation, like Windows registry access, like network, something like that. We only monitor important things that we believe that hackers will invoke. So basically, we will invoke those things. Okay. So basically, libraries is very important, huh? So the second thing that the malware do is load another library and another library, and then REG stands for registry. Okay, registry query value. That means the malware would like to access some configuration of Windows. So it it requests to, so that is a very long name, okay? That means the malware would like to know this Windows, okay, this system. What is the critical session timeout of this system? That means critical section means that is related to operating system. That is a time period, okay, which you can lock certain resources. Okay, basically the description is like this. So basically, the malware would like to know this information about this operating system, and then ask also, okay, request to know what is the timeout value of some resources, something like that, and so on and so forth, so on and so forth. Basically, in 5 minutes, okay, with this selected API calls, files, libraries, process, registry, and network. Okay, we have 5 categories of Windows API code to be monitored. Basically, in 5 minutes, thousands of API calls will be observed in these 5 categories. Okay, thousands. So basically, you have to do some research, or you have to make a classifier. Okay, given 2 API call sequences, and you have to classify this API call sequence belongs to malicious software or belongs to benign software。所以比较常见的这个dynamic analysis 应该这样，就是说在比如说我们现在选定了5大类的东西要观察嘛，哈，网络的、档案的、register 的，然后 library 的，还有就5大类哈。那大概在5分钟之内啊，我们就去观察这个坏人在做什么嘛，哈，大家都会得到上千个这样子的 invocation， 我们上面这范例是5个嘛，对不对？5个，你会大家得到上千个，所以啊，你就要想，你有没有办法做出一个machine learning 的 classifier， 给你看2条，大概都上千个或上百个的这样的 API code， 然后你就去判断说它是坏的，是 malicious software 还是它是好的。这也很困难哈，人看都很困难哦。你给我一个大概1000条的这样子的这个记录档，你叫我从第1个往后看到第1000个，然後看一下里面的 code， 然后还有 code 的顺序，然后它里面使用的参数，它 return 的值是成功还是失败。其实人很难看懂他想要的。人，如果你很有经验的话，你可以看懂他想干嘛啦，你就看那些 API code 的组合哈。但是我们就是期望说人不要做这种事情嘛，我们想办法交给 AI 做。所以你就叫 AI 去看这1条，比如1000个 calls， 然后配合它的 parameter 跟它的 return value， 然后去做一个 classifier 出来classifier 有很多嘛 ，SVM 啊 ，logic regression 都可以做 classifier， 对不对？你希望可以看出来说到底他在做坏事还是做好事。这是一个很困难的题目哈。So that is a very difficult problem to be solved given a sequence which contains the time information, the function information, the parameter used by the functions, and the return values. Okay, and maybe a sequence of API call. It has maybe 1,000 sequences, 1,000 calls in a sequence, and you have to build a classifier by using, for example, SVM, using logic regression, using trees, decision trees, to help us, which means security expert, to classify this sequence belongs to normal program or belongs to non-abnormal or malicious program. Okay, so that's a very tough problem. Okay, so here is another example called log money. It's MD5 006D. If you're interested in this, you can copy this MD5 value to VASTOG. Okay, you can see its detailed information. Okay, so here's another trace. Okay, something like that. Okay, that's another. Of course, there are several different systems that can help us to do dynamic analysis to record all the API calls invoked by malware. The above one is one system, okay? Its output is like this. The below one is another system, okay? Another system, and its output is like this, okay? You can see, take a look at this one, okay? That is the first 10 calls, okay, made by this low money, this specific malware, okay? How do we read this one? Okay, process number 1416, okay? It has a thread, that means thread ID. If thread ID 1420, okay? Now, at this moment, it executes a library, which is ntdll.dll, okay? And in this library, it invoked a function, and its name is RTL append Unicode to string. Also, that is a function. And then this function is at virtual address at this 7C914F1A as its virtual address. But basically, the useful information should be this one and this one. That means this malware, okay, execute a function called RTL append Unicode to string, and this function belongs to ntdll.dll library, and so on and so forth. So this part should be the important part where we do analysis. That means if you get this 10 calls in a sequence, can you identify what this malware would like to do and whether it is a malware or it is a benign software, and so on. So of course, there should be hundreds or thousands of calls in this sequence. Okay. 就是这是另外一个系统嘛，好，另外一种的输出长这个样子啊。那你的目标当然就是给你几百个或几千个中间这个矩形的这个call sequence， 啊，你怎么去判定他想干嘛，然后他在做什么啊？他可不可能是一个恶意程式还是一个善意程式？所以这就跟上面的问题一样，只是这两个 data format 长不一样，好，只是问题是一样，他们都是很困难的问题哈。Okay, here is another profile, dynamic analysis profile. Okay, its target is Android. Yes, it's a cell phone. So basically, you can make a copy of your Android app from your cell phone to a sandbox. The sandbox is built for Android operating system, so you can still execute the app, right? And we have a monitor which is called DDMS. Okay, that is the name of the profiler. Android has a built-in profiler, so you can activate this profiler, which is called DDMS. Okay, so you can record the interaction between your app and the underlying operating system. 好，就是Android 的系统里面有一个内建的这个观察器，好，叫做 DDMS， 好，叫 profiler。那你可以把它启动之后，你的 Android 的 app 啊，它跟下层的这个，因为它是用 Java 写的嘛，哈，它用跟下层这个 Java 的执行层啊，这个作业系统在互动的时候，他们到底在互动什么东西哈？所以结果看起来也很像。So I provide an example right here. So it's right here. Okay, so it's very similar. Okay, the first few lines right here. That means how for this Android application, how many threads has been created. So in total, this app create 17 threads to execute the entire app. okay, and it has a index and its name. Okay, 17, and the rest parts, okay, looks like this. It's exactly the same. This is the index of time. T time. And basically it is not in second, okay, it has another unit 就是后面这个是一个时间的标记啊，但它的单位不是秒了啊，这是一个时间标记。And here ENT and EXIT, that means enter. That means exit. Which means at this moment, 53, okay, this app, thread, number 4, they try to invoke a function, so it enters a function, okay? This function name is right here. And there are some parameters right here. 好，就是说在时间标记53的时候呢，thread 4号它现在 call 了一个 function， 就是 enter 这个 function。这个 function 名字就是那个 org ap APA7 一直到那个 dispatch 这里，后面还有一些其他参考的这个 parameter 啊，不要再进去了。那你知道我们一般写程式 function 都会再 call 别的 function 嘛，对不对？所以它的下一个又再 call 其他 function 啊。那当然也会有离开的时候啊，比方说。For example, at this moment, thread number 4, okay, exit a certain function at time index 65, which is right here. That means it returns from this function. 那你可以看到65号的这个就是 thread 在4号的 thread 4号在时间65的时候，它离开的那个 function， 那个 function 名字是应该是一个。整数的那个 constructor 整数的 constructor， 那它就离开了。也就是说，我们可以看这个表格来看这整个 app 在那些 thread 的运作之下，还有时间的排序之下，他们到底呼叫了哪些 function， 跟离开了哪些 function 啊？什么时候呼叫就是什么时候进去嘛？那你执行完了要离开那个 function， 就会有个 exit。OK。So basically, you can you can use this file to describe how an app has been executed on an Android operating system. So basically, these different profilers, okay, they output those logs, okay, those records. Those records can help you to understand how apps or Windows execution files being executed. Okay, so basically you have to write your own parser because they just upload a simple text file. So you have to parse those text files to certain data structure. I believe you have learned data structure before. So maybe it is an array or it is a linked list to store the time information, the function call information, the parameters, or the return values. By using your data structure. Okay, so basically I provide so here is the I write the class, I write the Python class to parse the first selected window API code, that function. So basically you can copy my code, okay, to analyze the log file. So we will have some homework. We'll have some homework that use the logs which I provide you. So you have to use this parser to parse the log I provided, and you use this files, the log files, to do some to build your own classifier or something like that to analyze this files. Okay, so here is the example. Okay, so basically you will have a lot of logs. You simply just apply, just fit them into the class which I provide, and then you can print. Okay, this is a log, has no parameter. The length is 250 consecutive calls. Okay, something like that. Okay, so take a look at this code. Okay, it is a parser. Okay, so can you write a parser? Okay, it's an open question we left for you. Okay, maybe you can write a parser for the DDNS file, or write a parser for the Windows and to the trace. Okay, so basically it's right here. Okay, and here the first things I would like to demonstrate is malware variant in the family. Okay, as I mentioned before, maybe the hacker, okay, it writes a certain malicious code. Okay, try to attack you, try to steal your information, try to do something harmful to your system. Okay, maybe. Okay, and the very first thing is he compiled the code, he tagged the code, and he distributed the code. Okay, so the next day maybe he needs some new functionality, so he rewrites some functions. Okay, and let compile again, tag again, and distribute the code to the internet again, and so on and so forth. So maybe there are some malware samples, they come from the same origin, which is the hacker. But they are slightly different because the code has been modified, or they apply different packers. So the code, appearance of code, the execution of the code is slightly different. And usually, we call those samples are variant， 中文就叫做变种了，好，这很简单了，就是一个生物的变种，好。And we call them as a whole malware family， 好，就是我们会称之它为是恶意程式的家族，因为它是来自于同源的地方嘛，好 ，same origin。那彼此之间可能就是 sibling 啊，或是一些祖父的孩子的关系啊，这关系以后你都可以做出来哈。那么我们现在就要变成就是说，那我们怎么知道我得到这个 sample， 另外一个 sample， 他们是不是同源的？他们是不是同一个 family 的？我们就可以做一个这样的东西。那是不是同一个 family 很简单嘛？我可以做一个 classifier 啊，我用 SVM 做一个 classifier， 是跟否嘛啊。那我就丢很多这个 malware sample 的记录进去，就问 SVM 说他们是不是同 family 的 ？Okay, so the first application looks like this. I collect a lot of samples. Okay, part of them are from the same family. They are malware variants, and part of them belongs to another malware family. Okay, and I have those training data. And of course, I will extract some features from dynamic analysis result and static analysis result. Okay, I can create a table to describe each malware samples. And I have their target Y, which is written, okay, it belongs to family A. And the other sample belongs to malware family B. And I can create a classifier, for example, an SVM, a tree, decision tree, logistic regression, something like that. And I can create a model, can help us to distinguish malware family A, malware family B. That's a very simple application. Okay, so basically, okay, here is an example. So I provide you malware sample, which is called more star. More star. Okay, so you can try it at home. Okay, using your Colab. Okay, try it at home, and we can it is zip file. Okay, so you can unzip this file. Okay, we can see that there are a lot of logs. For each log, it is recorded from one malware sample. For example, this one, the first one, okay, that means this malware sample is collect from 03AZ for blah blah blah. You can simply just copy this MD5 value to VASTotal, and it shows exactly which sample it is. Okay, so we have several different samples. Okay, as you can see that some file name, okay, their prefix 就是他们的前缀 are the same, okay, but their postfix is not the same, which means sometimes when we execute a malware, this malware will spawn another process. 中文再讲一遍。有时候我们在执行一个 malware， 就是我们拿到一个 sample 的时候，然后我们就在一个 sandbox 里面把它点开嘛。那你点开之后，你会突然发现，它就呼叫了 fork 的这个程式，然后把自己再复制一份出来，就是标准的用字叫英文用字是 spawn 就是它再生出一个新的 process 所以这一个可执行档你点开之后会有2个 process 或者3个或者更多看它怎么写的那我们会针对每一个 process 做记录，所以后面就会有后缀。所以这个意思是说03A142的这一个 malware sample 拿到 sandbox 上，然后把它点开来执行之后，它会有2个 process， 然后所以后面的后缀 process 那个时候就给了不同的编号1264跟13322。它们是2个不同 process， 所以里面的内容就分开记录。So that means when you get a malware sample, for example 03AZ AE, and you execute it in the sandbox. However, when you execute it, it forks 2 processes. So we will use 2 different postfix 1264 and 1334 to record the API calls invoked by 2 different processes. Okay, so we have 2 log files. Okay, so among them you can see that there are a lot of malware, right? A lot of malware logs right here. Some of them belongs to same sample, but some others belongs to different samples. Okay, so I think there are 31 or 32 files. Okay, in this zip file. Okay. So what is the next thing? Okay, the next thing is how do we present a sequence of API call? Because previously, okay, when we talk about machine learning algorithm, what is the data structure we talk about? A table, right? Right? And usually, okay, we know how to convert the table, okay, by using Orange or by using any Python code to apply different machine learning algorithm 就是我们之前学的 algorithm 都是以表格为主嘛，对不对？ However, currently we have sequence. So how do we convert sequence information, sequence data to a table? Because after we have these tables, we can apply different machine learning algorithm, right? So there's one important, it's right here, one important technique called one-hot encoding. Okay, that means, for example, I have a lot of different malware samples and I collect their Windows API invocation sequence. Okay, so basically, for example, that is family A, okay, family B, family X, something like that. So basically, it is still a classification problem, right? But what is exactly X1 means? Okay, there are 2 different ways, but the first one is not usable. Okay, the first one is since it is a sequence, so X1 can represent the very first call of this sequence, but this is useless. So X1, for example, X1 is the first call, for example, okay, X1 is the first call, so it call 1, the second call 3, call 1, okay, call 100, call 3, call 1, call 1, something like that, call 99. If you have only n calls to describe a call, and you can present it in this way. And you simply write down which call is called at the first place, S1, at the second time point, at the second point, X2, so on and so forth. 就是如果我们可以描述一个 sample， 用它的前 n 个 call， 那你就把它摆上去嘛。实际上这件事情是完全不 work 的。为什么呢？因为我们在执行程式的时候总是会有一些跳跃嘛，有一些 if else for loop jump 对不对？你说你第一个 call 是 C1， 你第二个 call 是 C3， 然后再来是有 C1。可是问题是，如果第二个人跟第一个人他是同源的，他是同一个骇客型的，可是呢，这个骇客在产出这个第二个 sample 的时候他就想说，我在前面应该要多记录一个现在的时间好了，所以他在前面写了一个记录时间。好啦，那你的第一个 call 就被因为前面要多一个记录时间的这件事情，对不对？所以你的整个 call 是不是就被 shift 一格到后面去了，对不对？原本你是 call 1 2 3 4 5 6 7，然后你现在第二版本的时候，你要记录时间，所以变成说 call 记录时间，然后才1 2 3 4 5 6 7，所以你全部都往后移一格。所以用这种序列的方式，直接写在这个 table 上，资料 table 上是不 make sense 的，因为都会有资料，就是有突然多插入一个call或突然少一个call前后这种东西。那每一个 call 在不同的 dimension 里面被讨论嘛，x1 到 xn。这个完全不 make sense， 好吗 ？Because those variants those calls, call sequence can add, delete, or replace by different call because the malware and the hackers might modify the calls. So you cannot directly put the sequence directly on this table. So that is not workable. So basically, we don't do this. Okay. Rather, we use a technique called one-hot encoding. Encoding. How do we do that? Okay, first, you have to know how many different calls that your monitor can observe. For example, as I mentioned before, Windows has 3,000 or 30,000 calls, and in our system maybe only 50 calls will be observed. So basically you write it right here, 1 to 50. I have 50 different Windows API will be captured, will be monitored by my profiler, by my system. So you write 1 to 50. And for the first sample, you simply just collect 5-minute traces, right? Logs, right? And you simply say, okay, in this 5-minute log, the first call, okay, maybe, okay, give me a name, load library. Is this call has been invoked within this 5 minutes? And you say, yes, this call has been invoked in this 5 minutes. Okay, the second one may be, okay, the file open. This call has been called by sample 1 in this 5 minutes, yes or no? Okay, maybe the answer is no, and you write 0 right here. And you can simply just finish all those 50 different calls, types of calls, by using a vector to describe which call has been called, has been invoked by this sample, and that maybe you have a Y, okay? It belongs to a certain family, and so on and so forth. Maybe you have another sample like this. So basically you can finish this. And then you have a table, right? So you can revisit our previous classes, okay? You can apply this table by using orange to apply any algorithm we taught before. Or you can apply this table. You can use this table to by using maybe write Python algorithms okay, to use this table to apply machine learning algorithm in Python to try to find a classifier. Maybe it's a SVM classifier. Okay, so that you can distinguish which family it belongs to. Okay, that is a very simple concept. Okay, we can use in one-hot encoding method help us to describe a sequence data. However, this kind of encoding totally ignore the relationship between calls. 中文讲没有？我们虽然可以很方便的用 one-hot encoding 方式把 sequence 的资料编码成这样1跟0，就是有没有用那个 call 嘛？好，我没有用那个 call， 但是它完全忽略了 call 跟 call 之间的相对关系，可以吗？比如说，假设有个 call， 就是比如说 file open 后面永远都接 file read 好了。假设我们写程式会有个逻辑顺序嘛，哈，那 file open 后面一定会接 file read。那这个关系你应该要想尽办法把它描述下来。可是在这个表格里面，我们并没有描述这个想法。我们也不知道 file read 一定在 file open 的后面或前面，或者他们一定会成对出现，后面它一定会成对不出现。这些东西，这些 information 完全没有在 one-hot encoding 里面。So that is one of the way we have efficient way to describe a sequence by using one-hot encoding. However, it is not the best way for us to describe a sequence of data. So next week we will teach you even more complex approach to how to describe a sequence data to a table, so that you can use the table to apply different machine learning algorithms. Okay, let's start right here. So take a look at these two dynamic static analysis topic. Okay. 好，就这样吧。